Welcome to Khetz tutorials, and in this video I'll be doing exponential functions. So I've previously done parabolas and hyperbolas, and this is one of the variations which we have to know, or which you have to know, and that is the exponential function. The exponential function has the following form: y equals to ab with the power of x subtract p, where b is greater than 0 and b is not equals to 0. So this is the general form of our exponential function, and we can note a few things about the exponential function. It has an asymptote at y equals to q. So if you notice, we don't have q in the formula. I had to put q in this formula, so let me just shift this, shift that to that point, and then input my q into the equation. So plus q, that should be plus q. So it's a b to the power x minus p plus q, and you have your asymptote at y equals to q. And so basically discussed what q does. Basically this describes the position of our asymptote, and we can come to p, which is found over here. So that's p over here, which we have, and that p is going to determine the horizontal shift. So horizontal shift, and these are the basics of our exponential function, and we can move on to discuss a, as we previously discussed, and b. So let's start. A, if we have an a of a greater than 0 and b greater than 1, you expect your graph to be above the asymptote. So for all values a greater than 0, you expect your graph to be above the asymptote. So after identifying your asymptote, or after finding the position of your asymptote, which is y equals to q, you therefore then have to decide if your graph is below or above the asymptote. So this exponential function only has, so here's another note, it has one asymptote, and it is a horizontal asymptote. So it has one horizontal asymptote, and it is positioned as at y equals to q, as I previously said. So now if you have an a which is greater than 0 and b which is greater than 1, then expect your graph to occur above the asymptote, and you expect your graph to be increasing. So your graph should basically look something like this. So let's draw just a rough sketch. You have your axes, or you have whatever the case may be. So your asymptote is going to appear anywhere. Let's say it's at the bottom or at the top, doesn't really matter. But what you must know is that your graph will occur above this asymptote, and it's actually increasing. So it'll have that shape over there. So it's going up, it's increasing, it's moving from this side to that side, which means it's increasing, it's going up. And so these points are shown in this graph over here. You have an increasing graph, and you have a graph which is above the asymptote. So if you have something like this, this is associated with an a which is greater than 0 and a b which is greater than 1. Moving on to another case where you have your a greater than 0. So let's come to another case of a greater than 0 over here. So a greater than 0, but now your b is now between 0 and 1. So your a is greater than 0, but your b is between 0 and 1. So what will happen in this case? So still the a is positive, so expect our graph to be above the asymptote, right? but now the graph is actually decreasing. So you can see, or you can just infer or conclude that your A actually determines whether the graph will be above or below, and the B actually tells you whether the graph is increasing or decreasing, right? For the case of A greater than 0, that is. So now let's draw the graph so we can associate this to a figure. So it should look something like this. Let's say this is your y, this is your x, so that is your y, that is your x. Maybe you have an asymptote which is above, somewhere there. Then expect your graph to look something like this. So the graph will therefore come like this. So let me shift this downwards so we have some space to work with. So I'm going to take this out of this over here. I'm going to take it down so we have some space to work with. All right, so I'm going to erase that. Okay, so we're going to say this is our y-axis, that is the x-axis, and our graph is going to look something like this. It's decreasing, but it's above, so it's decreasing, but it's above the asymptote. So that is when A is greater than 0 and your B is between 0 and 1. So now move on to the case where we might have our A less than 0. So the first case, you're going to start in the same fashion. You have your A less than 0, but you have your B greater than 1. The opposite actually happens here. So you have your graph below the asymptote, and you have the graph will be decreasing, right? So if you try to plot this, or if you try to sketch this, it should look something like this. So that'll be your y, that'll be your x, and wherever your asymptote is situated doesn't really matter. Let's say it's situated above, so let's say your asymptote is basically there. So you always draw with respect to the asymptote and not necessarily the Cartesian plane itself. So that is, we are only interested in whether the graph is below or is above the asymptote, because the asymptote, if you remember the definition of that, is basically a line where the graph actually approaches but doesn't touch. And so now, if we have a case where A is less than 0 and B is greater than 1, then we have your graph which is below the asymptote and your graph is decreasing. So it should basically look something like this. Let me choose green. It should look something like this. So it approaches, doesn't touch, but it's decreasing. It should look something like this. It's below the asymptote and it's decreasing. So now move on to the final variation, which we want to focus on, or which we want to talk about. And this is when A is less than 0 and B is between 0 and 1. So in this case, A is less than 0, so which means you know that the graph will occur just below the asymptote. So that is a given. Your A tells you where the graph will occur. So in this case, it will occur below the asymptote. But now our B is between 0 and 1. If you remember, for A greater than 0, with a B between 0 and 1, the graph was decreasing. But now in this case, for A less than 0 and having a B between 0 and 1, the graph is actually decreasing. And therefore, it will be the opposite of the one which we just looked at now, and it would look something like this. So it will look something like this. So there are two things again. This graph is below the asymptote because A is less than 0. But it is increasing. So that is all with regards to, we first talked about, so if you move up here, we first talked about P dictates the horizontal shift, whether, and this is whether the graph actually goes to the left or the right. And you have your Q, which is your asymptote. It determines whether the graph goes up or it goes down. So wherever we find the asymptote, it actually decides if you're going up or going down. If the asymptote is negative, then you expect your graph to start at the negative side of the y-axis, and if your graph is y equals to a positive number, then your asymptote will be at the positive side, and that is where your graph is basically going to start. So positive going up, or negative asymptote basically going up, and whether it's above or below, that will depend on the value of your a, as we previously discussed, right? And that is that. We are now going to move on to talk about the last section of interest, which is domains and ranges. So I previously talked about the domain and the range of all of the other functions, which I did in the previous videos, and we're going to do the same here. So if you remember, or just to recap, your domain is the range, or it's funny I said range in the domain, but basically that's an English term, range. It's not actually related to the domain, but the domain is, it explains the span or how large your x values are. So basically interested in where your x values start and where they end. So for something like this, if we are to analyze our exponential functions, you'll see that they are quite similar to parabolas in the sense that their x values go all the way to negative infinity. If you look at this green graph over here, the x values go all the way to negative infinity, and the positive ones go all the way. So the x value goes all the way from the negative, or from 0 to negative infinity, and from 0 to positive infinity. So you can essentially say, or we can see that the domain, or the x values which are covered by the graph, are x, so basically all real numbers, and that is basically from negative infinity to infinity. So all the x values are actually covered by this exponential graph. Doesn't matter if it's increasing or if it's decreasing, doesn't really matter. If you have a look, all the values are covered because the arrows continue to go in that direction, which is the left direction, as well as the right direction. So all the values are covered in that. So now move on to the range, and we analyze the range. So for the range, it depends on the kind of graph which you have, and I'll show you just now. So if you have a graph which looks like this, so if you have an increasing graph, let's say asymptote is here, doesn't really matter what the asymptote is, I just want to show you something real quick. So if you have this, which is an increasing function, and you also have something like this, which is a decreasing function and which is below, so if you have like something like this, so let's write another, or let's have another increasing function. So the main thing here is whether the graph is above or below, because even if we had an increasing function here, what I'm about to say would still apply. So now we're basically interested in if a is greater than 0 or if a is less than 0. So for a, we know that for a greater than 0, the graph is above the asymptote. We know that for a less than 0, the graph is below the asymptote. So now, to describe the y values which our graph actually covers, or which are included in the graph, we actually look at our asymptote, and we know that the equation for our asymptote is y equals to q, right? So you'll notice that I'm actually using a different type of software, and I had to change for some reasons. So let's just continue where we left off. So you're talking about the range of the exponential function, and since we know that the asymptote is actually given by y equals to q, each of these asymptotes, which are shown by the red dotted line, are given by this equation, right? We know that for sure. Now that we know that, we can actually define the y values which are covered by each of the graphs. So whether the graph is increasing, so for the first one over here, the green graph is increasing and the blue one is decreasing. And here you have your blue graph increasing and the green one decreasing. So whether the graph is decreasing or it's increasing, we're only interested in whether the graph occurs above or below the asymptote. So the range is the same as long as we know whether a is greater than 0 or less than 0. So for a greater than 0, we know that the graph occurs above the asymptote. And for all exponential functions which occur above the asymptote, the range will be y greater than q. So whether the graph is like here, whether the graph is increasing or decreasing, as long as it's above the asymptote, the range will be y greater than q, which can also be denoted as y is an element of q with the round brackets because we can't include the asymptote up to positive infinity. So it goes all on and on from the asymptote going upwards. And for this case over here, this case where we have a less than 0 and the graphs actually occur below the asymptote, you will notice that your y values will always be less than q or less than the asymptote. And this can also be denoted as, so y less than q can also be denoted as y is an element of, so starting from the small one, which is negative infinity, to q. Both of those with the round brackets to show that they are not included in the range. They just indicate all the y values which are actually part of the functions. So that was basically all which I had to discuss with regards to exponential functions. And if you like the video, just go ahead and give it a thumbs up. If you haven't subscribed, please subscribe to my channel. I'll see you guys in the next video.